Let me get back on track. Tokamaks will never work. Let me emphasize, because a spherical wave forms suddenly on one half of the wave, the magnetic field is facing the wrong way and nothing can be done. Instead of being contained in the center of the tokamak, this blob of hot plasma is violently repelled from one side and attracted to the other side of the reactor wall. This destroys the right-hand rule only containment strategy. I love how physics has symmetry. It is one of its beauties. The right-hand rule is not symmetrical. This new physics takes this apparent lack of symmetry and re-describes it in a beautifully symmetrical way. Anyhow, in a tokamak or any other toroidal device, these plasmoids and blobs will always be attracted to the reactor walls. That is the main reason why researchers have never been able to get their fusion devices to work before. Spherical waves are always catastrophic for the right-hand rule only machines. There is no solution that will enable tokamaks to work. All toroidal fusion designs will always fail. They are right-hand rule only machines. When the spherical waves form, the magnetic fields in the plasma curl two ways, both to the right and to the left, at the same time. Because their confinement fields curl in only one direction, it does not matter how big you make a tokamak. It does not matter how powerful you make a tokamak. The spherical waves will always form, and the tokamak designs will never be capable of handling these spherical waves. These spherical waves will always be stronger than the confining fields. Now, someone might argue optimistically that tokamaks can be made to work by using brute force, by creating some kind of sophisticated technique for spotting these blobs, these plasmoids, these spherical waves, for spotting them as they start to develop. Then, some method of compensating for them could be implemented. For that argument, I would ask, why? Why go through all of that expense and trouble? Simply plan ahead, knowing that these waves are going to form naturally on their own. Going a step further, it's perfectly logical to create these waves artificially on purpose before they naturally form in the plasma. When you plan for these waves ahead of time, the resulting machine is not a tokamak. It is my new design. Of course, these spherical waves are not really instabilities because they can be far more stable than the confinement fields of any toroidal device. Actually, these spherical waves are the most powerful type of confinement you can imagine. Look around yourself. If I'm correct, then in every elementary particle around you, the self-attracting symmetry of the electric, magnetic, and gravitational fields in the spherical wave keeps the particle stable. Physicists have long marveled about the amazing stability of some of the elementary particles, like the stability of the proton, the electron, and the neutrino. The fields in these elementary particles have a symmetry that makes them self-confined and stable. Thank God. Literally, if that wasn't the case, then they would instantly decay and all matter in the universe would immediately vanish. Each particle would explode into energy. Because spherical waves are the best type of confinement that you can imagine, that is why in my fusion power plant designs, I create spherical waves on purpose and use them for confinement. 99% of my fusion power plant designs use components that scientists and engineers already know about and understand, using parts like conductors, capacitors, resistors, inductors, high power switches, and lasers. These fusion power plant designs have only one detail that scientists will not be familiar with. It is the spherical electromagnetic wave. My designs have three main systems. I call them the ignition circuit, the confinement circuit, and the transfer circuit. First, the ignition circuit lights the fusion fuel on fire. It's kind of like a spark plug. Second, the confinement circuit confines the fusion burn. In the process, new electricity is created. Finally, in the transfer circuit, the newly created electricity is transferred to the electric grid. Visually, the confinement circuit is the largest part. It has conducting spheres located in troughs. In this example, the trough is circular. It contains a number of spheres I call conducting spheres. In this example, the conducting spheres are 1 meter in diameter and are made of copper. This prototype uses 4-inch copper spheres. The trough they are sitting in is made with cement. The size of the spheres is important. The diameter of the spheres is one of the most important variables. Personally, I would like to get enough funding for my fusion energy lab to test my designs with a wide variety of diameters. The 3 main sizes I would like to test are 1 meter, 2 meter, and 5 meter spheres. In this overhead view, we see a design with an oval layout. Earlier, I started my explanation of spherical waves by using the example of a pearl necklace. Here in this image, you can see why. Geometrically, the oval of spheres in a pearl necklace is just like the oval of conducting spheres in my fusion power plant designs. Earlier, I also showed this example. I took these spheres that have magnets inside of them and lined them up on a circle. I don't like this example because it can be deceiving. While visually it looks right, the magnetic fields are wrong. The magnets inside these spheres are just simple dipole magnets. This is a different type of geometry than the fields in a spherical wave. If you would like, go ahead and take advantage of my pearl necklace example as a conversation starter. If you are a woman wearing a pearl necklace and would like to test a man, then simply ask him if he understands the scientific significance of the geometry of the necklace. Of course, as a man, this gives you a new conversation starter with any woman as well, and she doesn't even need to be wearing pearls. Think about it. Obviously, my goal is this. For the rest of your life, you'll never be able to look at a pearl necklace again without, at least for a moment, thinking about spherical waves and this kind of fusion power plants. Think about this. A pearl necklace has a beauty, a symmetry that is inherently attractive. But have you ever wondered why? In this graphic is part of the design for a large commercial fusion power plant. In this particular confinement circuit, the oval track is relatively large. If each sphere is 5 meters in diameter, then this track would be roughly 45 by 70 meters. Depending on the number of spheres used, it could be smaller or larger. In high school, I was on the track team. I competed in shot put and discus. While I was not a runner, I spent a lot of time at the track. The conducting sphere trough for the largest power plants could be as big as the typical high school track. In my designs, a spherical wave is created along these spheres on purpose. The spherical wave is made artificially ahead of time. This is relatively simple to do. First, a very large, very powerful capacitor bank would be charged to a high voltage. In this graphic, the capacitor bank is out of sight below. This capacitor bank would be powerful. It would create a powerful, long-duration pulse of electricity. This pulse would flow through the power plant's hemisphere coils. In this graphic, there are 10 hemisphere coils over 5 conducting spheres along the bottom row. Notice how these hemisphere coils are placed over the conducting spheres. This is a simple example of a hemisphere coil I made. The wire is taped to this copper conducting sphere. This is trivial to test. When the current flows through the wire, it flows around the coil and induces a spherical electromagnetic field that flows over the conducting sphere. When you place this coil and sphere into a string of spheres, then any pulse in the coil will induce a spherical electromagnetic wave over the surface of any conducting sphere it is immediately adjacent to. However, the wave does not stop flowing over just the first sphere. If there are other spheres in a line or in a loop, then the wave will continue to flow over all of them. In the confinement circuit of my designs, these spheres are usually lined up to form circles or loops. However, my patent describes other unusual geometries. Anyhow, the spherical wave will flow around the loop of conducting spheres. By the way, there is no doubt about this. This is trivial to test. Using a hemispheric coil, you can easily make a spherical wave flow around a track of conducting spheres like this. Earlier, I mentioned I have a patent for a new way of conducting electricity. This is how it is done. A spherical wave is simply created over a series of conducting spheres. I know this works, but still, it requires further testing. I would like to test and intimately understand a number of variables. There are a large number of things that I would like to look at. I'll leave that to your imagination. The answers will determine how big the spheres need to be and inversely how small we can make the power plants. One question I'm really curious about is, are these spherical waves the essence of superconductivity? That would be a major breakthrough. That would be exciting, and not just because I have the patent. I would like to emphasize I do not describe these spherical waves as unexpected. Spherical waves are not unexpected instabilities. The critical difference is, for my fusion power plant designs, we make these spherical waves on purpose. In my fusion power plant designs, we do not wait around for the spherical waves to form naturally or randomly all on their own. We make these waves on purpose. We control exactly when the waves will appear. We control exactly where the waves will be. Not only that, we make sure they are powerful waves. With forethought and intention, my fusion power plant designs make very powerful, artificial spherical waves. As soon as a spherical wave is created, this spherical wave is flowing around the conducting spheres and over the core. Here is the core area of one design. The core is the central part of the ignition circuit. The core is normally a large metal sphere. The chief parts of the ignition circuit are a capacitor bank for the lasers, the core, some type of fusion fuel, and some controls. The spherical wave flows from sphere to sphere. The direction of flow could be clockwise or counterclockwise. The confinement circuit has solid conducting spheres. In the confinement circuit, the wave is flowing over the solid conducting spheres. In this graphic, the magnetic field is primary and is the only field shown, so the graphic isn't quite so busy. In the ignition circuit, the spherical wave flows over the core. In this example, the electric field is primary and all three fields are shown. This is how and where the two systems overlap and interact. In this example, the electric field is primary. In the core area, you can see the green gravitational vectors through the blue magnetic and magenta electric field vectors. Over the two adjacent conducting spheres, see the green gravitational vectors are not shown. The spherical waves sweep from sphere to sphere. A continuous unbroken chain of waves sweeps from the conducting spheres over the core. Again, this is where the two systems overlap and interact.